So I finally had a bit of spare time and got around to making the T-nuts for the press. These are going to be used for fixturing the parts in place. I was going to make them in the previous video, but I ran out of time. Speaking of which, this is part 2 in making a fly press for the workshop. In part 1, we welded up the base and machined in all the features, and in this video I hope to get the basic frame complete. Now to make the basic frame, I set aside these pieces of 75mm square bar stock. That's roughly 3 inches. Now these are heavy pieces of steel and they're going to be more than enough for a small fly press like this. But it should allow for some big welds since I'm going to have to weld this whole frame together. However, before I can do anything, the pieces will need to be cut to size, and whilst I could very easily cut them with a hacksaw, I had a friend who offered to cut this with his bandsaw, so I just did it that way. And once I got the blanks back, I could clean them up and square them off on the mill. And those are our blanks made. We have 5 pieces in total. 4 of them are going to be for the frame, and 1 piece will be set aside to make the ram block. Now fortunately, due to a small mishap, one of the end pieces is going to be 26mm shorter than it was supposed to be. Not a huge issue, these things do happen, but that will need to be accounted for. Now before I start welding, there are 1 or 2 things that I will do first. This block here is going to have the ram block guides sort of attached to it, and it's going to need some M10 holes to be drilled and tapped. Now 4 holes probably would have been enough, but this build is already overkill, so 2 extra holes wouldn't hurt. And I'll be using bolts to hold the ram guides on rather than welding it, simply because it's going to be easier for me to add later on, and it gives me room for better adjustment and alignment. It's better than it having it permanently fixed in place and then it being slightly wrong. And those are the 6 holes tapped. Before we can continue, we do have 1 more hole to tap, although when I say 1 more hole to tap, that's a lot easier said than done. So a few months ago, I don't know if you remember, I made these. This is a Sqaure Tap Set. The major diameter for these is 40mm and they have an 8mm pitch. And these are easily the biggest taps that I've ever made. Now the reason why I made them was in anticipation of this project. The square thread profile that it has is really suited as a power screw, at least compared to your normal 60-degree V-thread. Acme would have been slightly better for this type of job, but I wasn't able to form that thread profile with the milling setup that I was using. And as much as I really like this tap set, it's not all perfect. Now the pitch here is 8mm, which is very coarse, but with most fly presses, they have a lead screw that is a lot coarser than this. Most of them will use a triple helix or a triple start thread, which results in a pitch of easily 30 or 40mm. That's the reason why these fly presses are able to achieve a high impact force. Now unfortunately I won't be able to achieve that sort of impact, but I still will be able to achieve something similar to it. I still will have a flywheel and I still have a pretty coarse lead screw. 8mm on a small fly press will still have a pretty high impact force. The smaller pitch though will get us a higher screw force, since a smaller pitch will give us a higher mechanical advantage, which should be a good thing because we should get several tons out of this press. At the end of the day, the reality is I was limited by the equipment that I had, and this was a compromise that I had to settle on. Well, maybe at least. This is all dependent on if these taps actually work. I struggled a lot just tapping a solid puck of aluminium, and this time the challenge is a lot higher. This time instead of aluminium, I have to tap a solid piece of 75mm steel. So I guess wish me luck. First thing I have to do though is get the hole made. Now the hole that I need is 32mm, which I'll need to drill and then open it up with a boring head to its final size. And that is our hole made. Nothing else left to do but get the taps ready and, well, see if it works. And of course, to use the big taps, I'll get them set up in the big tap wrench. Now with the Sqaure Tap Set, the first tap that we go in is going to cut a physically smaller diameter than any of the other taps. You can probably see just how small the teeth are on that tap. This one here is only 34mm, so it's only taking a 1mm depth of cut. And despite only taking a 1mm depth of cut, there is still a lot of material to shear off, and it's going to take a lot of effort. And despite having the right tap wrench for the job, it was very slow progress, but I guess progress is progress. And you can probably see just how much everything is moving and flexing. You know, I put easily 100 kilograms of metal down on the workbench to weigh it down, and it was still moving a lot. And this can only end up one. I broke the workbench. The whole front where the bolts go to bolt the vise on just sheared off. In fairness, this was above and beyond what I ever expected this workbench to do, and it just couldn't take it anymore. However, even though I did break the workbench, I won't be deterred. And a few screws later, the bench was as good as new. Now to reduce all that binding that I was experiencing, I am going to do what I should have done at the very start of this project, and that's grind in some more relief into the back of the taps. I think that was responsible for a fair amount of the force that I was experiencing. Now I don't have a tool and cutter grinder or a surface grinder, so to do this I'm going to simply take a cup grinding wheel and use it in the milling machine. Now as long as you protect the ways and then clean them up afterwards to get rid of any of the grit, it shouldn't cause any harm to the milling machine. And on a tap like this, it's best to grind in the relief the full length of the tap. I'm not really trying to remove all that much material here either, it's simply just enough to prevent any binding when it's in the hole. And the before and after difference is quite noticeable. It's still quite difficult to move the tap, but it's not binding as it was before. I also sharpened it a little bit more, so that probably helped it quite a bit too. And that finally is the first tap done. And that is the thread profile that is being established quite well. With the profile now established, we can now follow it up with our number 2 tap, which will cut a 37mm major diameter. And if it all goes well, it will follow the same lead that we've already established. And thankfully, that is cutting quite nicely too. Lots of effort and a lot of cutting oil is needed, but the cut feels quite smooth and it's not binding. And the second tap went all the way through with no dramas. And the resulting threads are looking pretty great. Finally, we can go in with our number 3 tap and cut the full 40mm profile. And that, ladies and gentlemen, believe it or not, is our 40mm thread cut. And I for one am so relieved that I got it to work. For a moment there, I was really 50-50 on whether this was actually going to work, and if it didn't, I would have been in a bit of trouble, because I'm not exactly sure how I would have found an alternative to get this thread cut. I can't thread mill this type of thread, so it probably would have been some sort of custom fixture on the lathe, and redoing all the ratios on the gear banjo and the gearbox. Important thing though is I don't have to do that, and the threads turned out quite well. The big tap wrench also deserves a heap of praise too, just for holding up and not snapping on me. There is a bit of damage to the jaws since I didn't harden them, but I can't complain, and this is probably the hardest I will ever push it. In any event, repairing the jaws is very easy to do, just taking a few mils off the jaws using the milling machine. Also, big shout out to the taps for working and not breaking on me. Although next time, I'd definitely do a set of 4 or 5 just to reduce the cutting load, because this thing took way too long to cut. I think I spent about 3 afternoons doing this, and those were 3 very long afternoons. And these are easily the biggest taps that I could do by myself by hand, and no chance that I could ever do a tap with the multi-helix thread because that would just be too much force for me to do on my workbench and probably my vise. Now in retrospect, the taps could have gone a little bit longer in the case hardening process, or I guess made from silver steel, although I'm not exactly sure if I could actually manufacture these if I was using a high tensile piece of steel. As you can probably see here, I lost one of the teeth partway through, but thankfully I caught it just before it could do any damage. So I guess that'll need to be replaced before I can do any more tapping using this tap set. With that said though, I can't exactly see myself needing to use these anytime soon. The whole process has also lifted a bit of metal, so I'll get that fly cut. Now we should be able to get the pieces arranged so we can weld it up. Now the shape that I went for is just the basic F shape that can be found on a lot of other fly presses, although those ones aren't made from welded pieces of bar stock. Most of the ones that I've seen are solid castings of cast steel. Now I will point out here, this is not the strongest shape that I could have gone with, and it did take a few revisions to get here, but what this is a compromise between aesthetics, strength, and ease of making it. And that's one reason why I made sure to use SolidWorks, just to make sure that it could handle all the expected loads. And given that I went for a weaker design, it was important that I did this. But thankfully here we have a large factor of safety, and we will be okay. Before welding it though, I will first add some bevels and fillets. Bevels to give us some more weld volume, and fillets is mostly for looks. And with all that done and it looking really nice, we can now start to weld it. Now, unlike the base, which wouldn't experience much force and the welds didn't matter as much, I am going to be giving the frame a preheat before I weld it. Mostly to reduce the thermal differential between the two parts, and also to hopefully end up with a better result. And given the mass and thickness of the parts that I was welding, it definitely needed it. Now I started off with some MAP gas, but I later switched to an LPG torch. It wasn't the right nozzle for the MAP gas, and it wasn't doing a whole lot of heating. With the first piece done, I'll now get the second half welded. Now I won't be winning any awards for these welds, but they aren't porous, so I'll take that small win. I can now weld the two halves together to complete the frame. And once I finished welding, I can leave it overnight to slowly cool down. So it's been a few days, and I've made a few changes off camera. If you remember earlier, I said one piece was about 25mm shorter than it was supposed to be, and as a result, the whole frame needed to be 25mm or so moved forward, which I simply solved by milling a step down into the base. I've also added some bevels for the weld. And that is the frame welded in place. All in all, it looks really nice. The grinder managed to blend all those welds in quite well, and it makes me feel a lot better about my welding. It definitely feels quite solid, although the real test will be how it holds up to several tons of impact force. The final thing I want to do is add this back plate, which will fit underneath the frame. Now this piece really isn't all that necessary. You know, it will add a bit of side-to-side stiffness to the whole design, but it's mostly there for aesthetics. It breaks up the front and the back, and it makes it look a lot nicer. Or at least that's the theory anyway. And this time I thought it would be worth trying to TIG weld it rather than MIG it. You know, I might end up with a nicer weld. Or I guess not. I might need a bit more practice. And a bigger electrode too. And that is about it for this week. You know, we finally got the frame complete, and I'm really happy with how it is so far. Looking at it on the computer is one thing, but having it here right in front of you is just a whole new experience. And I think the final project is going to turn out looking really great. Super heavy though, and I'm not exactly sure how much longer I'm going to be able to move this thing around. This thing here is easily 35-40 kilos plus, and we still have a lot more mass to add. Now in the next video, my aim is to get the lead screw made, the ram block made, plus the guides machined. And at that point, we should be almost done. So I guess keep an eye out for that video, and until then, hope you enjoyed this video. See you next week.